All right, wanted to provide some statistical research insight. I covered this in one of the courses I teach at K-State, and just using this as an example. So one reason I'll show why I'm using this, but I also tend to know energy balance, weight loss, obesity type research better, so it's easier for me to use some of this and find some of these things in that type of research designs, and in this case, clinical trial or control trial, whatever the case may be. And in this study, the conclusion was isocaloric feeding following 10 to 15% weight loss. So what they did was they had a weight loss phase of 12 weeks, followed by weight stabilization, run-in diet, and then followed it up with randomly assigned and a crossover effect. So they each person who completed the study was exposed to a low-fat diet, low glycemic index diet, or low glycemic load diet, and very low carbohydrate diet. What they found was, and so their question was pertained to resting energy expenditure. What they reported at the end, based upon their means test, was that the low-fat diet resulted in greater decreases in resting energy expenditure and total energy expenditure. There were intermediate decreases, so in between low-fat and very low carbohydrate diet, and the lowest decrease, or the least decrease, was with the very low carbohydrate diet. So the practical application is, somebody reads this, they see not necessarily this conclusion. They may see that, but hopefully they'll dig deeper and look at the discussion, look at the results, etc. And when a potential issue when using randomized control trials is there's an assumption that it's cause-effect. And translating that to every person. So, why is that important? Why do I say that? So one reason. So this is a reason why I chose this study and studies like this to use, is that these are individual. The connected lines indicate individual outcomes for each participant. So each of these, this dot, and this dot, are from the same person. And so what that allows for is assessing how each diet affected participants individually. So, case in point, for this figure, here is the mean, this line here, and then it's the confidence interval is here. So 95%. So the bars indicate 95% confidence intervals. So I chose this person. I could have chosen some of these others, but this one had low fat, basically unchanged, indifferent, seemingly, from 0, from baseline, and then decreased the most with low glycemic index diet, and then the intermediate was very low carbohydrate. So for this person, it appears the low-fat diet was the better metabolic outcome if changes, less of a change, less of a delta or decrease in energy expenditure, it indicates a better outcome. We can debate that. So that's one point. And then for total, these are different methods that were used for each of these. So that's an issue. But these data points and participants, the results from these participants are interesting because they're very similar for low fat, almost identical. They overlap-ish. I guess if we were to zoom in on the graph, they wouldn't. But they have very different responses for the low glycemic index. Here, here, here. And then they converge back on the very low carbohydrate diet. And so the take home here is means tests do not necessarily convey cause-effect, because here are real participants following the study, and those participants did not conform to the means. The means were a collection of the individual responses and an average. And so it can be misleading to people to say with confidence that their response will track with the means. They will likely have an individual response. And so some may confer that, well, this is a reason why we need to do very low carbohydrate diet, because look, the average was less, there's less decreases in resting metabolic rate, or in this case, total energy expenditure with this diet. Okay, but there's some that had significant, more than almost 1,000. This person had almost a 1,000 decrease in their total energy expenditure. And so that's just a take home. Individual differences don't necessarily agree with the means. And so when you see a randomized control trial, remember that there could be individual differences. Some people may vary and stray from the means that were reported. And so it's not necessarily cause-effect in some cases. Now, we're better able to explain mechanisms with a randomized control trial. There's better internal validity with that. But when you translate that to patients, to clients, and consumers outside of this situation, you may find that some people may have a response more like this, a response more like these folks, or a response with these. So it's a gamut. The issue is, the tendency is for most people to have a similar type of response. I mean, so for one thing, why is this mean higher? I mean, it could be pulled by this person. That's, in essence, an outlier. Similarly, this person dropping down here, then going back up here, probably an outlier for this. And so when you look at change within individuals, it's kind of all over the place. And then you have some people that may not appear to change at all. So anyway, that's a take home. Hope you learned something. Hopefully this was valuable. And have a great day. And thanks for checking in and being interested in science. Thank you.